Greetings, dear students. In our class today, we'll be looking at Faraday's laws of electrolysis. Faraday's first law of electrolysis states that the mass m of an element liberated during electrolysis is directly proportional to the quantity of electricity Q passing through the electrolyte. That is, mass m is equal to electrochemical equivalent Z multiplied by quantity of electricity Q. Recall that quantity of electricity Q is equal to current I multiplied by time T. Therefore, mass m is equal to electrochemical equivalent Z multiplied by current I multiplied by time T, where I is equal to current in amperes, Z is equal to a constant of proportionality for each element and is known as electrochemical equivalent. The unit is kilogram per coulomb or grams per coulomb. Electrochemical equivalent is the mass of the element liberated by the passage of 1 coulomb of electricity. Also, the mass of the element deposited during electrolysis depends on the density ρ of the element, the area A of the cathode, and the thickness D of the element deposited on the cathode, which means mass is equal to density multiplied by area multiplied by thickness. Also recall that area multiplied by thickness is equal to volume. Since m is equal to ρ multiplied by A multiplied by D, m is also equal to Z multiplied by I multiplied by T. Equating the two equations, we'll have ρ multiplied by A multiplied by D to be equal to Z multiplied by I multiplied by T. Example 1. During the electrolysis of copper 2 tetraoxosulfate 6 solution, an ammeter shows a steady current reading of 1.0 ampere for 30 minutes, while 6.6 times 10 raised to the power minus 4 kg of copper was liberated. Calculate the error in the ammeter reading. The electrochemical equivalent of copper is 3.30 times 10 raised to the power minus 7 kilogram per coulomb. Solution. Ammeter reading is equal to 1.0 ampere. Time T is equal to 30 minutes. Multiplying it by 60 seconds to convert the minutes to seconds, we have 1,800 seconds. Mass m is equal to 6.6 times 10 raised to the power minus 4 kg. Electrochemical equivalent Z is equal to 3.30 times 10 raised to the power minus 7 kilogram per coulomb. From the equation, M is equal to Z multiplied by I multiplied by T. Current used, when we make I the subject, we're going to have M divided by Z multiplied by T. Substituting the values, we have for M being 6.6 times 10 raised to the power minus 4 divided by the product of 3.30 times 10 raised to the power minus 7 and 1,800. I will now be equal to 1.11 amperes. To calculate the ammeter error, we'll have current used minus ammeter reading. So ammeter error is now 1.11 being current used minus 1.0 being ammeter reading, and that will give us 0.11 ampere. Example 2. Copper of thickness D is plated on the cathode of a copper voltmeter. If the total surface area of the cathode is 60 cm squared and a steady current of 5.0 amperes is maintained in the voltmeter for 1 hour, calculate the value of D. Density of copper is equal to 8.9 times 10 raised to the power 3 kilogram per meter cube. Electrochemical equivalent of copper is equal to 3.3 times 10 raised to the power minus 7 kilogram per coulomb. Solution. Area A is equal to 60 cm squared. Dividing it by 10,000 to convert it to meter squared, we'll have 60 times 10 raised to the power minus 4 meter squared. Current I is equal to 5 amperes. Time T is equal to 1 hour multiplied by 60 minutes and 60 seconds to convert it to seconds, being 3,600 seconds. Electrochemical equivalent Z is equal to 3.3 times 10 raised to the power minus 7 kilogram per coulomb. Density rho is equal to 8.9 times 10 raised to the power kilogram per meter cube. Now the thickness D is what we are looking for. From the equation, rho times A times D is equal to Z times I times T, making D the subject of the formula will give us Z multiplied by I multiplied by T divided by rho times A. Now substituting the values, we're going to have 3.3 times 10 raised to the power minus 7 multiplied by 5 multiplied by 3,600 and divided by the product of 8.9 times 10 raised to the power 3 and 60 times 10 raised to the power minus 4. That will go down to give us 5.94 times 10 raised to the power minus 3 divided by 53.4. When we now press the calculator, we're going to have D to be equal to 1.11 times 10 raised to the power minus 4 meters. God bless you. See you in our next class. Thank you.